Hello class, today what we're talking about is modeling with exponential and logarithmic equations. What this means is they're going to give us some data and we need to come up with an equation that will fit the data, whether it's just points off an actual exponential function or whether it's real world data off a table and we're going to try and make something fit. Alright, so first we're going to start with just some points. Alright, so they give us 2 points that come off an exponential graph and we need to come up with the equation of the function. All right. So step one, we're going to take this point 1, 6, plug it into the x and y values in our general form here of y equals a times b to the x. All right. So x is 1, y is 6. This gives us 6 equals a times b to the 1. However, if you'll notice, we have 2 variables. And if we have 2 variables to solve for, that means we need 2 equations to solve it. So we're going to have to take this other point and plug it in as well. Alright, so y on the second point is 54, x is 3, so 54 equals 8 times b cubed. Now what we're going to do here is we're going to solve a in the first equation, the one that has the lowest exponent. We want to solve a in that one because it's easier. So what we're going to do is we divide both sides by b, because b to the 1 is just b, and that gives us a equals 6 divided by b. So now we know what a is. A is 6 over b. Kind of, we know what a is. We're going to take this, plug it into a for the second equation. So when we do that, we have 54 equals 6 over b times b cubed. All right. We need to simplify this. So 6 divided by b times b cubed is 6 times b squared. All right. B cubed divided by b is b squared. Divide both sides by 6. So b squared equals 9. Take the square root of both sides, and b equals 3. Just the positive 3, not the negative 3. Because if you remember, the base to our exponent has to be positive. Because if it's negative, remember that graph went like this. Went, kind of crazy, and half the numbers were imaginary anyways. So it's all messed up. So we only want the positive square root, which is nice. Now that we know exactly what b is, we can find out a. We can take this 3 and plug it into b right here. So a equals 6 over b. A is 6 divided by 3, which is 2. So a is 2. A is 2. B is 3. We take those, plug those back into our general form right there. And y equals 2 times 3 to the x. All right. So it's not too bad. All right, let's take a look at this. Here what we have is some real-world data. All right, the store sells trampolines. The table shows the number Y of trampolines sold during the X year that the store has been open. All right, we need to come up with a function that models the data, and then we need to know, can we use this model to predict the number of trampolines sold in year 15? All right, so what we're going to do, first, if we have this data, it's real-world data, we want to put this in a scatter plot. All right, so here it is in a scatter plot. And we look at this and we see that's increasing pretty rapidly, right? Each one is getting way faster than the other, right? A lot bigger increase. So this is exponential, which means we're going to do the exact same thing we did on that previous slide. We need to take 2 points, plug them in for x and y, solve for a, solve for b, solve for a again. All right? A, b, a. So we have to pick a point. It doesn't really matter which 2 points you use. Just pick 2 that look good. I would not recommend picking 2 points that are right next to each other. Leave a gap, leave a little bit of a space there to get a better spread. I would recommend starting with x of 1 because that's the easiest thing to deal with. All right? So we're going to plug this in. We're just going to use 1 and 4 because why not? No reason. So take these 2 points, plug them into your equation. Y equals a times b to the x. So we have 12 equals a times b to the 1. And 36 equals a times b to the 4th. Solve the first one for a. So we're going to get a by itself. We're going to divide by b to the 1. Or divide by b. I'm going to put this over here. All right. Take this a value, plug it into a for the second equation. So 36 equals 12 over b times b to the 4th. B to the 4th divided by b is b to the 12th. So we have 12b cubed equals 36. Divide by 12, take the cube root, and b equals the cube root of 3, which is approximately 1.44. take this cube root of 3, plug it back into our a equals. So a equals 12 divided by cube root of 3, which is about 8.32. So plug that into our equation, and there's our function. Y equals 8.32 times 1.44 to the x power. Now, could we use this to predict the number of trampolines in the 15th year? Well, let's plug that into our calculator. Turn it on. There it is. 15th year, so x is 15, and that gives us 1,970, approximately 75 trampolines, right? So in 1 year, we are going to sell more than we have sold every other year combined. Not so much. No, that doesn't quite work. We can graph it, and you see that increases at a pretty big pace, right? You can look at the table, and you can see there is quite the disconnect between year 14 and year 15. That is a little over 600 trampolines increased in 1 year. And the year after that, we're going to sell almost 1,000 trampolines more than in year 15. That may not be entirely reasonable. Exponential equations are usually only good in the short run, okay? Only after the first few years. Looking at this table, it might be good. Here's year 7. Here's year 8. That's still a pretty sharp increase. It might be okay for year 8. Possibly year 9, but probably not after that. The increase is just getting way too big there. All right, so exponential models are usually only good for the short run. Okay. Now, what I want you to do is pause the video, work out these 4 problems, then come back, check your work. All right, let's see how you did. So here's our answers. For number 3, you should have 3 times 2 to the x. Number 4, 1/2 times 4 to the x. 5, we have y equals 64 times 1/2 to the x. 6, you should have something kind of close to this. Won't be exact. Depends on which 2 points you used. So number 3, if you did not get this right, we're going to work it out. If you did get this right, congratulations, you can skip ahead to the next slide. So number 3, we start with our y equals a times b to the x. We plug in our 2 points. So 12 equals a times b squared, x and y. X and y, so 24 equals a times b cubed. Solve for a in the first equation, the one with the lowest exponent. So a equals 12 divided by b squared. Take that, plug that into a in the second equation. So 24 equals 12 divided by b squared times b cubed. Well, b cubed divided by b squared is just b. So we have 24 equals 12b divided by 12 on both sides, and b equals 2. Take your b value, plug it back into the first equation. 12 equals a times 2 squared. Not that, b squared. 2 squared is 4, so for a we divide by 4, and a equals 3. Plug a and b back into our original equation, and we have y equals 3 times 2 to the x. Number 4 works exactly the same way. Plug the 2 points into 2 separate equations. Solve the one with the lowest exponent for a, so a equals 2 over b. Plug that in for the second equation. 32 equals 2 over b times b cubed. B cubed divided by b is b squared, so we have 2b squared. Divide by 2 on both sides, 16 equals b squared. Take the square root, b equals 4. Remember, we're just taking the positive square roots. Plug the 4 back into the original to equation number 1. So 2 equals a times 4 to the 1, or just 4a. Divide by 4 on both sides, a equals 1/2. So there's our a, there's our b. Number 3 does the same thing. Plug the 2 points into 2 separate equations. Solve for a in the equation with the smallest exponent. Plug that in for a in the second equation. Solve for b. So b is 1/2. Take that, plug that back into the first equation. So 16 equals a times 1/2 squared. 1/2 squared is 4. Divide by 1/4. Divide by 1/4 to both sides, which is the same as multiplying by 4. A is 64. A is 64. B is 1/2. Number 6, you're not going to get this exactly. Just pick 2 points. It doesn't matter which 2 you pick. You're not going to be exact, so you might as well you're going to get close. Pick 2 points. I picked 0.1 and 0.7, just to have that whole big spread in there. Hopefully it's a little bit closer. Alright, solve for A in the first one with the lowest exponent, so A is 15 over B. Plug that into the second equation, so 140 equals 15 over B times B to the 7th. B to the 7th divided by B is B to the 6th, so we've got 15B to the 6th. Divide both sides by 15, and we end up with 28/3 equals B to the 6th. Take the 6th root. B is approximately 1.451. Plug that back into our original, so 1.451 to the first, divide by 1.451, and A is approximately 10.338. So my numbers are slightly different than these, but you see they are pretty close. They're pretty close. That being said, this is how you work it out by hand. Now I'm going to show you how to do it in the calculator. Any graphing calculator will solve these, and we'll come up with the equation for this. And that's what we're going to do. We're going to take that same trampoline. This is the equation we have calculated. We're going to let the calculator do it. So, step 1, open up your calculator. You're going to put these into the stat lists. X is in Y1, Y is in L2. Sorry, X is in L1, Y is in L2. This is for the TI 82, 83, 84, 95. Not the Inspires. Those look different. If you've got a Casio, it looks different. But this is for the TIs because it's what I got. Go hit stat again, go to calc, just like you would do for a linear regression or quadratic regression. We're looking for exponential regression, which is way down here, option 0 on mine. Enter. We are going to save this into Y1. Actually, we're going to put this in Y2. Calculate, and there it is. Alright, so we've got our new equation here. Y equals A, 8.457, so approximately 8.46, times B, 1.42 to the X. Which one's better? I don't know. Well, let's just plug in the next year. This plug in X equals 8. So we have 154 according to our equation that we calculated a minute ago. We have approximately 140 according to the equation the calculator comes up. Which one's better? Well, the calculator one is better. Ours just used 2 points. The calculator used all 7 points. So it was a more exact answer. Also, if you notice here, we have this R-square value. It doesn't have it on my slideshow, but it has it here. This is the correlation coefficient. It shows how close you are to the right answer. Since this is really close to 1, this is a really good answer. All right. Now, we can also do this with logarithmic functions. So here we have air pressure as a function of altitude. The higher you go, the lower the air pressure. And it tells us we want to do this using a logarithmic form in this function here. And so all we're going to do is we're going to take this, plug this into the stat list, and this time we're going to do ln reg, which is under the stat calc. Down here, it's actually above exponential. There it is, right there. Natural logarithm regression. And you do it the same way. Put in your stats, do the ln reg, gives you this equation here. You see r squared, it's really close, so it's good. And you just take A, plug it in for A, B, plug it in for B of X. And there it is, that's your equation. We want to estimate the altitude when the pressure is 0.75 atmospheres. So we take 0.75, plug it in for P in this case, and type in the calculator, hit enter. It's about 2.7. Now, what I want you to do is pause the video, do this one. This one's a logarithmic regression, so you're just going to do it in your calculator, and then come back, check your work. Let's see how you did. Type this into your stats. You did your regression. This is what you should have gotten. And here's how that looks. Here it is in the stats. You do your regression. You should have come up with this. And then you can just type in 7, because that's what it wants us to predict. When the tree is 7 years old, how tall is it? Type it in the equation, plug in 7 for X. Not a bad deal. That is how to model with logarithmic and exponential functions. Plug in 2 points or use your calculator regressions. I hope this